welcome back to another episode here from the Off-Grid Garage in Australia. Good afternoon, it is. So, after the initial shock that the JK BMS is not working correctly, we can all relax, we can all breathe normally, we can all keep ordering this BMS. Well, if you want it. And the main thing is we can keep testing it, which I want to do today. The initial test I wanted to make was to fully charge the battery and see how the active balancer of the JK BMS, JK, I said JK again, JK BMS, how the balancer of the JK BMS reacts when the battery is fully charged. Can it cope with the rising voltages of single cells? Can it keep them under control? And can it prevent from reaching the 3.65 volts? This was the main test when I discovered this voltage issue. Well, if you don't know what I'm talking about, watch the last two videos. I'll link them down below if I don't forget. And you know what kind of weird behavior this BMS had. I don't want to spoil it. Okay, so before we start with this test here, I want to fully charge the battery. And we want to see if the JK BMS can actually handle the situation and prevent any cell from reaching the overvoltage disconnect. Plug in the BMS again. And I think we will have the same feature as before. Now this is all good. Okay, so and after plugging in the balance cables, the BMS is not turned on. We have to apply a 4 or 5 volt higher voltage across B- and P- to turn on the BMS. Or we can just connect the power supply or a charger with a higher voltage to trigger the BMS to turn on. Once it's turned on, it will stay on. This is just for the initial start. Okay, I've now connected the charger to a P- and the positive of the battery, and we are slowly increasing the voltage now, and see, and the BMS turns on. Well, it will beep. There we go. There's our confirmation beep, and now we can turn down the charger again. And we should be able to connect via Bluetooth. Yes, here we are. Okay, I'm just taking the negative off. So, the battery has settled now during the night to 3.335. We've got 7 millivolt deviation only. We just check. Oh, we have to put the password in. Yep, this is all turned on, so normal operation if you have the discharge on as well. Okay, so the cell overprotection will kick in at 3.65 volts. I will increase this to a 3.7 volt. Okay, this is all good. 2 amps balancing. Status. 3.65 times 16 is 58.4. Okay. Yeah, 58.38, that's fine. Let's connect the negative, and there should be current flowing. And we go full blast, 5.1 amp. See what the BMS does now. Start balance volt, 3.4, yes. We've got 10 millivolt deviation only, but this will increase very soon. Well, I don't know, maybe it does take longer. Okay, I'll be right back. Okay, this takes longer than expected actually. I thought we were almost there. Because we recharged the battery to 3.6 volts the other day, you remember? So I'm not sure why it takes so long. But anyway, I'll probably show you the setup here for our test number 2 today. Yes, you're getting 2 tests in one video. Where else do you get this here on YouTube? 2 tests in one video for free. Only here on the Off-Grid Garage in Australia. Okay, so we've got our 16S battery here fully charged. Well, at some stage fully charged. We have our BMS connected here, and we have an ampere meter connected here, a power meter connected. Gives us all the details. I've included here the shunt, and I have disassembled one of the no-arc breakers here from our battery shelf. I don't want to do this test without breakers, and I only have AC breakers so far, and they only have 25 amps, so I would need to parallel them, and this is just not good. I said, well, just get one out of the shelf here and use a proper DC breaker. the good old Xijia 3 kilowatt inverter here. Good old times. And you may have seen already, I have put the earth cable onto the earth screw here already, and have also put our MAN link in there. So one of the outputs here is now the neutral and the other one is the active. I have to do this because this inverter provides a floating output voltage. So the 240 volt output is floating. It is not linked or related to any earth potential at all. So, and this is exactly what I have done right now. There, you can see it better. So we're coming from the earth cable here and then screwed it on one of the terminals. This is our neutral now and the other one is the active. The reason for that is, first of all, we can use a portable RCD for safety reasons. And then we've got our meter here to measure the energy coming out of this inverter. Because I want to dump all this energy of this battery here into the Tesla. The Tesla is about at 50% state of charge now. And we will use the full 15 kilowatt hours or whatever we get, maybe 12 or so, I don't know, of this battery here and charge the vehicle. So we've got a nice steady discharge current of around 40-50 amps or so, I hope to get. So we can stress test the BMS, measure the ampere hours we get out of the battery here, see what the BMS ampere hour column count says, and we also can see later on the kilowatt hours we have actually pushed into the car from here. Is this still charging here? I'm done with my introduction here of the test number 2 and it's still charging. 3.4 we're seeing, slowly ramping up. Jeez, I had this 3 kilo ohm resistor on the battery for about 2 days since I did the last video. I wasn't expecting it to discharge the battery that much. Well, there was only the BMS and the resistor connected, nothing else. Here, this little guy here. It's a 3.3 kilo ohm actually. 3.3. 2 watts it has. And now we can see the balancer is active. We are over 3.4 volts with our cells. Actually all of them. And we still have a deviation of only 11 millivolt. That looks pretty good. So number 4 is our lowest cell at the moment here. And currently it is discharging these blue flashing cells. Number 16, number 2 now. So it takes a bit of energy here and there. Puts this in the supercapacitor. And then it discharges the whole energy into cell number 4. There we go. And now cell number 9. 4 and 9 are the lowest cells we have at the moment. Yeah, voltage is rising. Okay, I'll be back when we are at 3 point something volts. I'll watch the deviation here. So just a quick update after a few minutes. Cell number 8, cell number 12, 3.5 volts. And the lowest one is 3.466. 39 millivolt deviation. Balancer is working hard. But the question is, are 2 amps enough to balance the pack if we still charge with 5 amps? We still have about 2.2 volts to go. Pack voltage until we reach the 3.65 per cell. That's the goal. Still trying to discharge the higher voltage cells. Cell number 6 is the only one under 3.5 volts. Now cell number 9. Everything else is over. Cell number 8, 3.55 already. That's 50 millivolt. Yeah, 54 millivolt difference. Man, they better hurry up. Okay, we've got 3.6 volts and 57.5 we have. It is now increasing here. Yeah, this is due to the voltage drop now on these small cables from the power supply to the BMS and to the battery now. 3.616 we have. And cell number 5 is still under 3.55, just reached 3.55. Number 9 as well, 6 and 9. Why is it always cell number 6 with me? 3.64, 3.65 we have reached, and still charging with, there we are over voltage, and we are soon hitting 3.7. I just lower the current here a bit, so the cells have time to catch up. 81 millivolt deviation. Well, nobody is charging their batteries to 3.65 volts, right? Yeah, now we can see it's discharging these cells here. Number 12 now, voltage is going down very quickly, under 3.65 volts again. And we are still charging with 1 amps, 1.3 amps or so. I haven't calibrated the ampere meter here. I should actually. Okay, so after a few more minutes we are almost there. 58.4, there we are. This should be 3.65 volt across all the cells now. Some of them are a little bit over. 3.659 we have here. 51, 57, and some of them are still a bit under. We've got 21 millivolt, 18 millivolt deviation now. And we are still charging with 500 milliamps here from the power supply. Okay, give it another few minutes and then we are good to go, I think. So what I found, not a surprise, if the current here is under 2 amps, the balancing is actually successful while charging. Because as long as you put more current into your cells than you take away with balancing, they are still getting charged and the voltage is increasing. But I guess not many people will charge their batteries to a 3.65 volts on a daily base, right? So usually you charge to a 3.55 or even 3.6 maybe, and then you've got a little bit of overhead still left. If one of your cells goes a little bit higher, it doesn't exceed 3.65 volts. And the balancer has enough time then to catch up. Well, this one tells us actually we are at 58.6 volts almost. We've got 58.44. This one tells us 58.5, and we've got 58.37, and the Unity tells us 58.3 it was. So which one to believe? Okay, I guess we have to set some parameters here in the BMS. What I did is now the cell under voltage protection, 2.55 volts. This is when I consider the battery completely empty. If one of the cells hits that, that's it. Maximum discharge current. This should be a bit higher than only 5 amps. We set this one to 100 now. And some people have commented under the last video because the maximum charge current is only 25 amps for this BMS, which sucks totally, right? So let's increase this one here to 100 amps. Are you happier? You can configure all these settings here as per your needs, and for the test 25 was enough, but now we need more. No, actually we don't need more because we are not charging the battery, we are discharging it, and the discharge current is at 100 amps, and I think this is pretty much everything we need to set. These are the temperatures. I'm not worried about them. MOSFET temperatures, and this is pretty much it. Most importantly, cell under voltage protection 2.55 volts. That is set, and the maximum discharge current is on 100 amps. And that's pretty much it. Okay, so we are now at 58.45 volts, it says up here, and deviation 4 millivolt across 16 cells at 6.555555 volts. I think we can call it now. We're still charging with 100 milliamps. It would balance it down to 1 millivolt if we leave it like this, but I mean, that would be ridiculous, right? What we need to do now is we need to pre-charge the capacitors of our inverter here, right? But with a isolator, it is not that easy because you have both negative and positive disconnected from your source. Connect this positive here with this positive on the output here. Yeah. So we're bypassing the switch. And now with a second cable, we will have our resistor here and just pre-charge it. Once it's pre-charged, we can turn on the breaker and everything should be fine. Okay, wish me luck. Yes, I'm wearing my glasses. Yep, there's a little tiny spark. Okay, that should be good. Let me turn this one on. There we go. Oh god, jeez. That is loud. Okay, we can take off these switches now. That was the first scare moment. And we should be able to turn on the Xijia inverter. It turns on 58.4 volts. Wow, that is a lot. That is a lot. Yep, it's ramping up the voltage. You can see here 239.99 volt, 240 it shows us there. So the next step would be to plug in the vehicle. Yep, that is good. We've got a green light. So this is important that I've done this ground cable bridging to the neutral. So we've got an MEN link basically here on the inverter. And now we can start kilowatt hours 0000 there. We've got this one all reset and we start charging, right? Let's do it. Okay. 2 watts. So this one should ramp up now. Oh, fan comes on. 2,900 watts. Okay, I need to turn down the car a little bit. That's a bit too much. It's a 3 kilowatt inverter, so you can't do it, but not for several hours, you know. Oh yeah, this sits on 12 amps. Okay, we're going down to 10 amps. That's 2.4. Still a bit high, right? That's 10 amps. So we have 46 amps here going out of the battery at the moment through the BMS. Let's see if we can confirm this here. This one shows us 54. Let's see what we have here. 47.4. So this one is not correct. This is 46, 47, and this is 48, 47.7. So yeah, something in between there. So that's in between this one here and this one, actually a bit lower, 0.2. Okay. All right, and straight away we can see we've got 117 millivolt deviation, and cell number 6, who believes it, is low, and it's jumping up and down. So there's a connection issue. I need to check the connection. I need to check the connection of cell number 6. 1, 2, 3, 4, 5, 6. Here, number 6. Oh yeah, that's a bit warm here. Are they all a bit warm? No. No, it's only this one here. No, it is still jumping back and forward here. That's not good. I should stop the test and take off this terminal there and check it. All the other ones are fairly stable, but this one is jumping down from 2.9 to 3.1. Yeah, it's a bit warm here. Well, they're all a bit warm, but yeah, not like that. Well, it could be one of these ones as well here, right? Or these neighboring cells here. No, still jumping. Okay, I have to stop the test, interrupt it, and check for the terminal. Okay, I have now replaced both bus bars here leading to cell number 6 with the Paul's special super aluminium bus bars here. There should be no issue anymore unless cell number 6 is faulty. Maybe I haven't tested this one here, I don't know. Well, we will find out in a second. Okay. Start charging again. I think the charger has a fault now because I've disconnected the battery and the inverter was on under voltage. Open the charge port again. Now that looks better. Yeah, because I disconnected the whole battery here, everything turned off basically, and the inverter had an under voltage situation then. 2.3 kilowatts, 2.4 kilowatts we are pulling, and there cell number 6 is fixed. Nice. Thanks to Paul's super aluminium bus bars. Link is down in the description. Now these bus bars, they are amazing, they are really good. Okay, so we have only pulled 4 ampere hours now out of the battery here. What else can we get here? The 2.47 kilowatts, it says 250 watt hours roughly. Does this get warm here? Ooh, oh yeah, that's 100 amp shunt only, and we are pressing almost 50 amps through it. 47, 48, 49, 50, 51, 47. This one jumps up and down here all the time. And this one says 47, 25. Just scanning. Yeah, 25 degrees. Our ambient temperature here is 21 at the moment. Here. I've set the circuit breaker to 80 amps. You can adjust it from 100 amp to 80 amps only. Isn't that cool? These cables are getting... Oh, this is 60 millimeter cable here. That should be good for 100 amps. This is all good. This is all good. This is all good. And these cables here. I was trying to get... See, this is a 7 gauge wire here. And I was trying to get a 10 millimeter ring terminal onto these 7 gauge wires, which didn't fit. So I had to use a 16 millimeter ring terminal, and this fitted actually. So, and looking at these ones, this is 16 millimeter cable here. Same here, you can see them next to each other. Well, this is a 16 millimeter as well, but this is double insulated here, welding cable, really high quality cable. I've got the links on my website here for these cables. They are superb. Based in Brisbane company, the cheapest on eBay, but really high quality cable. Really nice. I've got a shelf full of them, and this is actually good. What we can see here, the red number, which is our lowest cell, is jumping all over the place. So that's the third cell I'm seeing now since I turned on the camera. Number 4. So this is good. It doesn't stick to one cell, which is your lowest. It moves across whatever it can find is the lowest at the moment. That is perfect. And the same with the other one, with the blue one. Goes across your whole pack. So really nice balanced. So what is our expectation? 280 divided by 50. That's 5.6 hours or 5.5 hours. I guess we will see about 4 hours, close to 5 hours maybe. And then we have reached 2.55 volts with one of the cells. Okay, I'll leave this running here. I'll come back to check I'll stay here for a moment. Just watching, observing and measuring some temperatures. Make sure everything is correct. This gets a bit warm here. That's fine. There's 10 amps. There, 10.2 amps. 2421 watts. Alright, we have just passed the 2-hour mark of our test here. Have discharged 95 ampere hours or 5 kilowatt hours. Something is... I think it's the shunt here. Oh yeah, oh, the shunt. Oh. Yeah, 46. It's alright, 110. That's alright. And you can smell it. It is getting warm. Okay, let's do a quick temperature check here in Fahrenheit. This one has 80 degrees. It sounds a lot to me. Okay, 27. 27, that's alright. Let's check here, 29, 30. Okay, that's the cable here itself. The inverter. Amazing. The cooling works so nice here in these inverters. says 4.9 kilowatt hours discharged. I tell you, these Xijia inverters, they are really robust inverters. I would not be able to do the test with the Victron one. Well, the Victron is a 3000 VA inverter. This is a 3000 watt inverter. So this can do a little bit more. But the Victron, if I pull 2 kilowatts, that's the max. And in summertime I cannot do this. Well, this one here just ramps up the fans here and stays cool. The blue and red number are still flicking across all the cells, which is good. And we still have a deviation of about 50 millivolts, sometimes 40, 45, 55. That's all good. What I dislike a bit on the app here is it is very nervous. You can see how the numbers of the voltages going up and down, they are changing all the time. Main voltage, amps. It is very nervous. Interestingly, the MOS temperature is 30 degrees only inside the BMS here, and it is really not even hand warm. It is relatively cool. BMS claims we have 64% left in the battery, which is 180, almost 180 ampere hours left. And apart from that, nothing else to report. Okay, I shall be back in 2 hours. Then we will see how far we are. Alright, and we have just reached the 50% mark. At least this is what the power meter here claims. We have used 140 ampere hours. The BMS says we have got 137 ampere hours left. There you can see it. So they're almost identical. 48% it claims we have left as per the BMS calculation. And I'm still very pleased that our high and low cell are all over the shop. There's no cell peeking out at the moment. Looks like the delivery here from Qishou technology from Shenzhen is very good quality again. So far. Okay, we do a quick checkup here. 28, nothing has changed. 27, 26, got even cooler. This is the shunt, still on 46, 47 degrees, which is 116 Fahrenheit. 25, yeah, it's cooler up here, normal. Man, this thing is rock solid. Apart from the loud fans, okay, it's running full blast now on 80% of the 3000 watts here, but it is just working. We should integrate this inverter somehow here in the installation. I'll think about it. And we have discharged 7.44 kilowatt hours now of the battery. So at 50% that would mean 14.8, 14.9 almost, and that would be amazing if we can get 15 kilowatt hours out of these batteries here. That would be insane. Yeah, it's me again. We have now discharged 10 kilowatt hours out of this battery here. Amazing. 192 ampere hours. And what else is good? 4 hours we've just passed. So that's pretty good. The BMS claims we've got 29% left in the battery, or 83 ampere hours. So 83 plus 193 is 6. There are 4 ampere hours missing then, right? 4. I think this is pretty good actually, between 2 different systems measuring the same current here, doing column count. 4 ampere hours out of 280. That's okay. And the average voltage has now dropped to 3.21 volts. And I can also see that our red voltage here, that our low voltage cell is between 9 and 10. So that's where it sticks now for quite a while. The blue one is still all over the shop, but red one sticks 9 and 10. MOSFET temperatures 30 degrees. Look at this here. Here, from my friends in America, 83, 82, 81. Look at this. Cold. Cold. Here, inverter. 80, 79. Honestly, if you are looking for a good inverter for your RV, for your cabin in the woods, whatever, the Xijia inverters here are brilliant. They are amazing. I've got all 3 dogs with me here in the garage because we've got a little bit of thunderstorm going on. And they are so scared. Oh my god. It's rumbling a little bit outside. Look at the watchdogs here. Okay, I think we give it another hour and see how far we are with the battery then. And here are the battery temperatures. We are around 25 degrees Celsius across the board. So they have actually warmed up a little bit during this test. So this is like 76 Fahrenheit. You can feel they are not cold anymore, but they are less than hand warm. That's all good. And now look at this. I need to speak up a little bit. It's a bit loud. We've got heavy rain outside. So you can see all these cell voltages here from the BMS, and they are all just under 3.2 volts. Sometimes a bit above, sometimes a bit under. But they are very close together, still 46 millivolt deviation only. And this has not changed since we turned on the whole system here. We are now down to 19% state of charge, what the 55 ampere hours remaining. And we've discharged 11.4 kilowatt hours, 220 ampere hours. Nice. Well, so far I'm very happy. Here, look at this. We've got 48 millivolt deviation now. We had 44, 45 all the time, and now it's going up to 50, sometimes 55, 60. So we are slowly coming down. The BMS claims we've got 8% state of charge and 24 ampere hours left. And here our power meter tells us we've got 250 ampere hours discharged now. 13 kilowatt hours gone. That is pretty good so far, and it's still going. We are still at 3.13 volt average cell voltage. There, 40 millivolt deviation. I could also sneak the battery temperature sensor number 2 into our battery pack here. Here it is. And here was a gap, and I could push it really down so we can see the temperature of the battery pack now as well. 27 degrees. Oh, we're having the first cells showing a 2.999. We've got 2% left, 7.8 ampere hours. And here the power meter says we've discharged 267 ampere hours, 13.8 kilowatt hours so far. Nice. And it's still going. So I think we are coming very close to an end now. All cells are under 3 volts now. You can see the overall voltage, 47 point something 2 volts, and it's dropping now. 0% remaining, 2.3 ampere hours as per calculation. So we've discharged 272 ampere hours so far, 14 kilowatt hours and counting. That is very nice. Battery temperature 29 degrees here inside this gap. And you can really form it. It's nice and warm now, the battery. Yeah, I don't think we will reach the 280 ampere hours here, but again, we have to see it's a 16S combination. It's a battery built out of 16 separate individual cells. And we can still pull 270 ampere hours out of them. That is very, very good. And this is also with totally unoptimized bus bars and connections to the terminals. These are just the old bus bars which came with the first delivery here, and they are scratched and marked and fucked up already. So I just took them to connect the battery here. This will be all much better once we have the aluminium bus bars in place. They've got full contact around the whole terminal. Much better. Okay, now we have to watch the cell number 10. Do we actually have a, what is it called, under voltage protection 2.55? Does that mean it will turn off exactly at 2.55 as soon as it hits 2.55, just 1 millisecond? Or is there a delay somewhere? Discharge, overcurrent protection. This is just for the current. No, not for the cell voltage. So as soon as number 10 hits 2.55, it will turn off. We are at 0.0 ampere hours now, 0%. BMS cannot count any further. We can hear the fan is slowing down inside the inverter here. It's working much harder than before. And the current also has increased here from 48, 47 to 52 now, because the voltage has lowered, but it still needs to provide the power for the electric vehicle charger. Okay, 2.6 now I can see at cell number 10. And before we cut off now in a few seconds, I just want to measure the temperatures here again. 27, so this has not moved here in the BMS. That is super cool. 80 Fahrenheit is. Inverter has actually cooled down. 21, 25 is the hottest here at the end. And here the battery is again around 80 Fahrenheit. 2.6. Look at this, 277 ampere hours pulled from this battery. How good are these cells? Well, 2.5 I can see, 2.59, 2.58. Let's see if it just turns off right now. Oh, 2.55 I could see, 2.555. There it is. Ah, it is still going. There is a bit of a delay, obviously, because I could see 2.55 already. That 2.51. We're still going. There it is. Protection cell under voltage. There it is. Nice. Look at this. 278 ampere hours pulled. 14.3 kilowatt hours. Alright guys, so far this amazing test from today. I'm really pleased with the performance of the BMS and the Qishou battery cells they delivered me. Yeah, I think I can go that far and give this BMS now the Andy approved award here. So far I cannot find any flaw. If you turn discharge on, it performs very well. The app is very well made, easy to program, no glitches. Was running almost 6 hours on 50 amps, 2.5 kilowatt pass through, doesn't get warm, and it just seems to work. So if you are in the market for a good BMS, I can really recommend the JK BMS from JK BMS. Now, it's really good. I cannot complain at all. Also, the batteries here from Qishou, very good quality here. Almost 280 ampere hours out of a 16S pack. That is not often that we get that. Usually from single cells, yes, but in such a formation here, you usually have a bit less capacity available. As always, guys, all the product links are under the video, in the links on my website if you are interested. starting from the Xijia inverter here, which is doing extremely well, the power meter with shunt, the JK BMS, the cells of course, and PowerPaul's Busbars made from good Australian aluminium. Alright guys, until the next video, you stay charged and stay safe guys, and thank you again for watching. See you then, bye bye. It's good!